Hello everyone. In today's video lecture, we will study about selection sort. In data structure, we have different sorting techniques and selection sort is one of them. In selection sort, we initially have an unsorted list of arrays or we simply have an unsorted list of data elements and we try to sort those elements in ascending or in the descending order. Okay, so in order to sort the data elements, we have two main approaches. Number one approach is recursive approach and the other approach is iterative approach. Okay, and in this video lecture we will be using iterative approach to arrange the elements by using selection sort algorithm. Okay, and as I said that we are using iterative approach, so there will be number of rounds in the iterative approach, so or simply you can say there will be number of passes. Okay, so initially we have a list of unsorted data elements. For example, we have the list of n elements and let's put them in the array form. So we will have a list of unsorted elements with indexing as a0, a1, a2, so on up to an minus 1, and this is for a list of unsorted data elements where the size of that list is n. Okay, and now when we go with the iterative approach, so we have different number of rounds. In round 1, what we do is we find the smallest element from elements of the unsorted list. Okay, we find smallest element from unsorted list and we also note down the location of that smallest element. Okay, and then we swap this smallest element with the first element of the list. We swap the smallest element with the first element, and what is the first element in our case? This is a0. Okay, and for the round number 2, what we do is we again find smallest element, but this time we find the smallest element out of the list that ranges from a1, a2 to an minus 1, because we have already swapped the smallest element with the first element, that is a0. So now the rest of the list is starting from a1 up to n minus 1, and we find the smallest element out of that list and we try to swap that element with the first element, and in this case the first element is a1. Okay, and we repeat this procedure until we reach to the end of the unsorted list, and finally by doing so we get the sorted list. Okay, and now for more understanding or for more clarity, let me write all the steps which are involved in this algorithm. Okay, I have written all the steps that are involved in the selection sort algorithm as round 1, round 2, round k, and up to round n minus 1. So in the first round, what we do is we find the location of the smallest element in the entire array. Entire array means the unsorted list of the elements, that is a0, a1, a2 up to a n minus 1, and we find the smallest element out of this list and we also note down the location of that element. Okay, and then we interchange a0 and a location. Okay, a location means the smallest element in the array. We interchange that element with the first element. Fine, and here in this case first element is a0. Fine, after that in the round 2, what we do is we find the location of the smallest element in the sub array. Sub array means we are leaving apart the element number 1, which is a0, and this time we look for the smallest element in the array which starts with the element a1 and up to an minus 1, and we interchange the element a1 and the element at a location, and then the elements a0 and a1 will be sorted. And in this case the element a1 either be greater than or it will be equal to a0. Okay, and then in the round k we move ahead in the list of unsorted array, and we find the location of the smallest element in the sub array, that is ak plus 1, ak plus 2 up to an minus 1. This time we have reached in our algorithm to some elements at kth position, and for the kth round I am telling you that we have to find the smallest element out of that sub array. So we find the location of that element and we interchange that element which is the smallest element with the first element of the sub array, and here in this case first element is ak. Okay, we go on interchanging the smallest element with the first element of the sub array, and then we get the sorted list of elements like a0, a1, a2, ak are sorted now. Fine. And then we go to the last round, and in the last round we find the location of the smallest element in the sub array, and now for the last round we are left with the sub array as an minus 2 and an minus 1, and we interchange the element at location which we have found for the smallest element in the sub array and with the first element. Okay, we interchange these two elements and we get the final sorted list as a0, a1, a2 up to an. So therefore we can say that after n minus 1 iterations we get the list of sorted elements. Do not worry if you are not understanding these rounds. I'll take an example and you will understand better from that example. Now in order to understand the working of selection sort, let me take the example of an unsorted list. For example, we have an unsorted list, and this is a list of 7 elements, and we have to sort this list in ascending order by using the selection sort. So first of all what we do is let me write here unsorted list. Now for its solution let me put these elements as an array: 20, 35, 40, 100, 3, 10 and 15. Let me put these data elements in the array. Okay, this is the given list, and now we will start with the round 1. What will happen in the round number 1, or you can say in the iteration 1, say this is the list, and in the round 1 let me assign the indexes to these elements. So total we have 7 elements in this list. We have to find the location of the smallest element. So here in this case the smallest element is 3, and here I will write it as small, and location is equal to 4. Okay, so the index for this smallest element in this unsorted list is 4, and in the first round what we do is we find the location of the smallest element and then we interchange the element at that location with the first element. Okay, so we interchange elements a0 and a4, that is we are interchanging 20 and 3, and after interchanging what we are going to get, we are going to get another list. Okay, that we will see in the round 2. Now in the round 2, after interchanging the elements 20 and 3, we have an array like this. Okay, and now what we see in the rest of the array, that is ranging from a1 to a6, we have to find the location of the smallest element, and out of these all elements we find the smallest element is 10. So I will write here smallest element is 10 and its location is 5. Okay, so what we have to do is in the round 2 is we have to interchange elements a1 and a5. So interchange elements a1 and a5, that is we have to interchange 35 and 10, and after interchanging we will get a new list that I will show in the round 3. So after interchanging, the new list will be like this. And now in the round 3 what we do is we will find the smallest element in the rest of the array, the sub array that will start from a2 to a6. We have to find the smallest element, and the smallest element here in this case is 15. So I will write here smallest and the location is 6. So what I have to do in this round is I have to interchange elements a2 and a6, that is element 40 and 15 will get interchanged and I will get a new list that I will show in the round 4. So after interchanging I will get a new list like this. Okay, and now in the round 4 I have to find the smallest element out of the sub array that starts from a3 to a6, and I have to find the smallest element. So in this case the smallest element is 20, so I will mark it as smallest, and location of this smallest element is equal to 4. So what I have to do is I have to interchange the elements a3 and a4, that is the a location. So interchange elements a3 and a4, that is we are interchanging elements 100 and 20. So after interchanging I will get a new list, and that new list is shown in the round 5. Now in the round 5 what I have to do is I have to find the element that is the smallest in the sub array, and the sub array starts from a4 to a6. Sub array starts from this point and the smallest element here is 35. So I'll mark it as smallest, and location of this smallest element is 5. So what I have to do here is I have to interchange elements a4 and a5, that is we are interchanging elements 100 and 35, and after interchanging we will get a new list that is represented in the round number 6. Now in the round 6 we have to find the smallest element out of the sub array, and that sub array is from a5 to a6, and here the smallest element is 40. I have to mark this element as small, and location of this element is 6. So what here we have to do is we have to interchange elements a5 and a6, that is we are interchanging 100 and 40, and after that we get a sorted list as shown below. So this is our sorted list. Now you have seen that for 7 elements we have undergone 6 rounds, and in the similar fashion I can say that if there are n elements in an array that we have to sort, and for that we have to undergo for at least n minus 1 rounds by using the selection sort algorithm. Okay, so this is how this algorithm works, and now let me write the program or the function that will have line of code that will be used to implement this algorithm. So this is a complete function that will do a job of selection sort algorithm, and this function can be called for the implementation of selection sort algorithm. So let me take the same example in order to just do the dry run of this function. And the example for that, let me take the same array. So when we call this function just to sort this array, and first of all what we have is, we have value of I is equal to 1. From this line I can say that I equal to 1, I is less than n minus 1, n is 7 in our case, so I is less than, okay, this condition is true. I is incremented here by 1, and here small equal to ai minus 1, small equals to ai, I is 1, 1 minus 1 is 0, a of 0, that means this, so small is equal to 20, and location is equal to I minus 1, which means that location is equal to 0. And now I am entering in the j loop for j equal to I, which means that j is having value 1 this time. J is less than n minus 1, yes, it is true. And then we check the condition whether a of j, which means that this element a of 1, this element is less than small. Is it less than small? Is a of 1 is less than 20? No, it's wrong. Okay, so this will not work, this will not work. We will come out of the loop, and again j will be incremented, so j will be incremented as 2. Fine, j is less than n minus 1, this is true. Okay, then a of j, which means that a of 2, a of 2 is 40. Is it less than small? Is it less than small? No. Again condition, this is false, so this will not run, this will not run, and we will go back to j, and j will be incremented as 3. And now we have to check this condition, is a of j, that is a of 3, that is 100, less than small, small is 20? No. Again this condition is false, this will not run, this will not run, and we again go and increment j is equal to 4. So now we check this element a of j, which is a of 4, that is 3. Is 3 less than small? Yes, now this will work. Okay, is 3 less than small? Small is 20, yes, 3 is less than 20. In that case we will have value of small is equal to a of j. A of j means 3. A of j is equal to 3. Okay, now the small is 3, and location will be updated as j. J is having value 4, so location is 4. Okay, we will come out of this j loop now, and then if location is not, we will come and check this condition. If location is not equal to I minus 1, okay, location is 4, I is 1, 1 minus 1 0, is location is not equal to I minus 1, yes, this condition is true because 4 is not equal to 0. Then we will have temp equal to ai minus 1. Okay, ai minus 1 is 20, that is 1 minus 1 0, so temp will have a value 20, and ai minus 1, ai minus 1 is 0, a of 0 will have a value of a location, that is a of 4, a of 4, which is equal to, what is a of 4, that is 3. So a of 0 will have a value 3 now. Okay, and then after these statements, now a of location will be updated as temp. Now what is the value of temp? Temp is 20. So a of location is 20. So what is a of location? A of 4. So a of location will have a value 20. So this 20 will go to this location. Okay, and then we will go back and the value of I will be incremented. But before that we have a list, we have a different list like this. A of 0 is 3 now, 35 will be here, 40 will be here, 100, 20, 10 and 15. This is A0 now, A1, A2, A3, A4, A5 and A6. So this is the result of first round only, and after that the value of I will be incremented. I will become 2, and we can repeat the same procedure for the second iteration or the second round. So after first iteration we have seen that the smallest element has taken its position at A0. So in this algorithm we are trying to arrange the list in the ascending order by using selection sort. Rest of the rounds you can try yourself. Okay, so now we will write a complete program in the compiler and we will see its implementation in the compiler. Now before the implementation of selection sort algorithm, let's do the analysis of this selection sort algorithm for time complexity. During the algorithm you must have noticed that for the round 1 or for the first iteration you require n minus 1 comparisons to find the location of smallest element, and for round 2 we require n minus 2 comparisons, and similarly for round k we require n minus k comparisons to find the smallest to find the location of smallest element. So in the similar fashion we can say that for the last round there will be only one comparison. For our case that was between n minus 2 and n minus 1th element in our case. Okay, so in total we can say that the selection sort function, this can be represented as n minus 1 comparison plus n minus 2 comparison plus n minus 3 comparison, so on up to n minus k comparisons plus so on plus 3 comparisons, 2 comparisons and 1 comparison. So this is nothing but the list of or the addition of first n minus 1 natural numbers. So it is represented by a formula that is n into n minus 1 upon 2. So this function can be represented as big O of n square. So this is the worst case scenario. This is the maximum time that this algorithm will take to implement the selection sort. Okay, so here the time complexity is represented by big O of n square. So this is all in this lecture, and in the next lecture we will come up with a new sorting technique. So thank you for watching.